Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll sketch this function using the concepts of derivatives. So the function is f at x equals x plus 3 over x squared minus 4. So the first step is to find the discontinuities in this function. So for that, we should factor this function as much as possible. Now this is a rational function and we can factor the expression in the denominator. So the first step is so we can use difference of squares to factor the denominator. So we get x plus 2 times x minus 2. Now we can see that there is no common factor in the numerator and the denominator. That means this function has no holes. Now we can find the vertical asymptotes in this function. So vertical asymptotes exist at x values that make the denominator equal to 0. So we have to set both factors equal to 0 and solve for x. So the first one is, and from this we get x equals negative 2. And the second factor is, so this function has two vertical asymptotes, x at negative 2 and x equals 2. So these are the vertical asymptotes. Now we can find the horizontal asymptote. So for that we have to analyze the degree of the denominator if we want to use the limit method to find the equation of the horizontal asymptote. So the degree of the denominator is 2 because that's the highest power on x in the denominator. So that means we have to divide each term in this function by x squared. So x raised to the power degree of the denominator. So we get over now we can simplify this expression and apply the limit x approaches infinity to find the horizontal asymptote. So x over x squared becomes 1 over x. In the denominator, x squared over x squared becomes 1. Now we know that 1 over infinity is equal to 0. So if we apply the limit, so 1 over x will become 1 over infinity, which is 0. Similarly, 3 over x squared will become 3 over infinity squared, which is 0 over 1 minus. Now 4 over infinity squared will become 0. So we'll be left with just 0 over 1, which is equal to 0. So that means the horizontal asymptote in this function is y equals 0. Now we should check whether the curve approaches the horizontal asymptote from above or below at the left and the right hand side of the x-axis. So for that, we'll have to apply the limit x approaches a big negative number and a big positive number. So let's start with the left side. Now we can apply the limit. So in the numerator we get a negative result, and in the denominator we get a positive result because negative 100 squared is 10,000. So the overall value is negative. That means on the left side the curve approaches the horizontal asymptote from below. Now we can do the analysis on the right side. Now we can apply the limit. Now in the numerator we get a positive result, and in the denominator we get a positive result. So the overall value we'll get is positive. That means on the right side the curve approaches the horizontal asymptote from above. Because a positive value will be greater than the zero value that we got for the horizontal asymptote, and the negative value that we got for the left side is less than the zero value that we got for the horizontal asymptote. Now we can find the intercepts for this function. So let's start with the x-intercept. So for x-intercept we should sub in the function value as 0. So we can cross multiply the denominator. So 0 times x minus 4 will become 0. Now we can solve for x by subtracting 3 from both sides. So the 3's on the right side get cancelled out. So we get x equals negative 3. So the x-intercept is negative 3, 0. Now we can find the y-intercept, and for that we should sub in x as 0 in the given function. So we will get 3 in the numerator and negative 4 in the denominator. So this is the y-intercept, and as a point it can be written as so we are done with the intercepts. Now we have to find the critical points for this function, and for that we'll have to find the derivative of this given function. Now this given function is a rational function in the form of a fraction, so we'll have to use the quotient rule to find the derivative of the function. So as per the quotient rule, we start with the derivative of the numerator. So the derivative of x plus 3 is 1 plus 0, or just 1, times the denominator minus the numerator expression times the derivative of the denominator. The denominator is x squared minus 4. So as per the power rule, the derivative of x squared is 2x. and derivative of 4 is equal to 0, so we can ignore it, over the square of the denominator. Now we can simplify the expression in the numerator. So in the numerator, 1 times x squared minus 4 is just x squared minus 4. And now we can distribute the 2x in the parentheses x plus 3. So we get negative 2x squared and then negative 6x over x squared minus 4 squared. Now critical points are points where the first derivative is equal to 0 or undefined. So we have to find the x values at which the prime of f at x is equal to 0 or undefined. Now before we do that, so we should simplify the expression in the numerator. We can combine the like terms in the numerator. So we get prime of f at x. So we get x squared minus 2x squared is negative x squared. And then minus. Now we can start by setting the derivative equal to 0 and finding the critical numbers. So we can cross multiply the denominator. Now this is a quadratic equation we have to solve, but we cannot use factoring to solve this equation. So we'll have to use quadratic formula. So as per the quadratic formula, minus. Now we can simplify this expression. Now under the square root, 36 minus 16 is 20, and we get two cases. So for the first case, I got negative 5.236, and the other case I got is x equals negative 0.764. So these are the two critical numbers at which the derivative is equal to 0. Now we can sub in these x values in the given function to find the y values so that we have the critical point. So if we sub in x as negative 5.236 in the given function, so we get negative 5.236 plus 3 over negative 5.236 square minus 4, which is equal to so in the numerator I got negative 2.26 and in the denominator I got 23.6676, which is equal to negative 0.1. So almost negative 0.01. No, almost 0.1. Sorry. So the first critical point is now we can sub in x as negative 0.764 to find the second critical point. So in the numerator, I got 2.236 over and I got negative 3.4163, which is equal to negative 0.65. So the second critical point is now we can find the critical numbers at which the first derivative is undefined. So we got the first derivative in the form of a fraction. So the x values that will make the derivative undefined are the ones that will make the denominator equal to 0. So in the denominator we have x squared minus 4. So we should set it equal to 0 and solve for x. So we got x equals plus minus 2, which are also the vertical asymptotes. So these are the two critical numbers at which the derivative is undefined. Now we have to find whether the function is increasing or decreasing on the left hand, the right hand side of these critical numbers. So for that we can use the number line method. So we can show these critical numbers. So we can start on the left side. There's negative 5.3236, then negative 2, then negative 0.764, and then positive 2. So we can use a test value on both sides of these critical numbers. So on the left side of negative 5.236, we can use the test value negative 6. On the right side of it, we can use negative 5. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Now to the right side of negative 2, we can use negative 1, and to the right side of negative 0.764 we can use 0, and to the right side of 2 we can use 3. So we have to sub in these test values one by one in the first derivative expression. So if the first derivative is greater than 0, that means the function is increasing, and if the first derivative is less than 0, that means the function is decreasing. So prime of f at negative 6, so negative over now in the denominator the expression will be positive because there is a square on the outside of the expression, so we always get a positive result in the denominator. Now in the numerator, so negative 6 square is 36, and so it becomes negative 36, and in the second term negative 6 times negative 6 is positive 36. So the first two terms will cancel out, so we will get a negative value, negative 4 in the denominator, so the overall value will be negative. That means the function is decreasing on the left side of negative 5.236. Now we can do the test for negative 5. Now the denominator will be positive, and in the numerator negative 5 square is 25, so it becomes negative 25, and then negative 6 times negative 5 is positive 30, so negative 25 plus 30 is 5, and 5 minus 4 is 1, so we'll get a positive value. So that means the function is increasing on the right side of negative 5.236. Now we can use the test value negative 1. Now the denominator will be positive, and in the numerator, so negative 1 square will be positive 1, so it will become negative 1 because of the negative 1 outside, the negative sign outside, and negative 6 times negative 1 is positive 6, and then so 6 minus 1 minus 4 will give us a positive value. That means function is increasing on the right side of negative 2. Now we can do the test for x equals 0. Now for x equals 0, we'll get a negative result in the numerator and positive in the denominator. So the overall result will be negative. So the function is decreasing to the right side of negative 0.764 and to the left side of 2. Now we can use the last test value. So we'll get a positive value in the denominator, and in the numerator we'll get a negative value because all terms are negative. So the overall value will be negative. That means the function is decreasing on the right side of 2. So now we can use the results of this analysis to sketch the function. So I can draw the grid here. So let's start with the vertical asymptote. So -2 and +2. And the horizontal asymptote is at y equals 0. Now we can show the x-intercept. So the x-intercept is at -3, so somewhere here. And the y-intercept is 0, -3/4, which is -0.75, so somewhere here. Now we can analyze, show the behavior of the curve around the horizontal asymptote. So on the left side, the curve approaches the horizontal asymptote from below, so like this. And on the right side, from above, so like this. Now we can analyze the function with the increasing and decreasing intervals. So on the left side of -5.236, so that's our critical point, -5.236 and -0.1, so that will be somewhere here. So the function is decreasing. So the curve is going down from left to right because it's decreasing. And then it passes through the x-intercept and then goes along the curve, along the vertical asymptote in the upward direction because the function is increasing. So this point here is -5.236. Now to the right side of the vertical asymptote at x equals -2, the function is increasing, so it goes up like this all the way to the y-intercept, and then it's decreasing on the other side. Now there is a critical point at -0.764 and -0.65. So the critical point can be shown like this. So it's somewhere here. So at that point, the tangent is horizontal. So this is our critical. And then on the right side of the vertical asymptote, the function is decreasing and it's approaching the horizontal asymptote from above. So this can be the sketch of the function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.